Okay guys, we're going to have a little video on law of sines. Law of sines is what you use when you can use this for any triangle if you're looking for angles and sides. Before, we've been dealing with right triangles, and right triangles, of course, use the Pythagorean theorem, but this formula you can use for any triangle. Okay, so in this example, first of all, in this here, this is where you have side A over the sine of angle A equals side B over the sine of angle B, and that's going to be equal to side C over the sine of big C, angle C. Okay, so let's say like in this example right here, we're given angles A, B, we're not given C, we're given that angle A is 40, angle B is 25 degrees, and then we're given the side of C is 20. Okay, and this is little c, by the way. Now here we can solve for angle C because all three angles have to add up to 180. So that means that we have 40 plus 25 plus C, which we don't know at this point. I put it in, but plus C is equal to 180, and here we can solve for that because 40 and 25 is 65. 180 minus 65 is going to be 115 degrees. So here we would be able to get that angle C is 115. What I don't have is side little a and side little b, but we can get that by using this formula. Now when you're doing this and you plug in the information, you're not doing all three of these at one time. You're just using any two of what you're looking for. So for example, let's say that I'm looking for a little a. I'm just going to use, first of all, you have to have two of the same things in order to use this. If you don't, then that's another formula that we'd have to use called law of cosines, but we're not there yet. So here we see that we can proceed with this because we have both the C's. So if you have both the A's or if you have both the B's, you can solve for something. And we don't have both of those, but we do have the C's, so we can use that. Okay, to save time, I kind of already have this set up here. So remember, you have to have two of something to be able to solve for anything. And here I have both the C's. I need the little a. And I do know that the sine of big A is going to be 40 degrees, so I can use that here. So let's plug in the information that I do have. This means that I'm going to have A over the sine of 40 degrees. That was big A. And this is going to be equal to the side of little c, which is 20 over here. And this is going to be over the sine of angle C, and angle C right here is 115 degrees. Okay, now how am I going to solve for this? I'm going to cross multiply. So if I cross multiply it here, I'm going to say, okay, A times the sine of 115 degrees is going to be equal to, cross multiply here, 20 over the sine of 40. Okay, and let's solve for what I want, which is that little a. If you have the trig function of a angle measurement, this is just a number. Okay, so if I don't want the number, just like if I had like 10 times a, you would just divide by the 10. Here I'm going to divide what I don't want, which is going to be that sine of 115 degrees. And if I do that, that's going to cancel right there. And it's going to give me a is going to be 14.1847531. But I can just, let's just do a 1 decimal place. So I can just say that A is going to be 14.2. That's fine. Okay. And then we'll do the same thing for B. Okay, and if we do this and we're going to be looking for a side of B, let's plug in our information. Angle B is 25 degrees. And of course we have our information for both the C's. Side C is 20 and angle C is 115 degrees. So now if we cross multiply, we're going to wind up with B sine 115 equals 20 sine of 25 degrees. And then I just want little b, so let's divide away that sine of 115 because I don't need that. That's just a number. And if I do that, that cancels there. We're going to wind up with b is going to be equal to 9.32615 3, blah, 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 blah. So I can just say that B is going to be approximately 9.3 degrees. Or 9.3, it's not degrees. Okay, 9.3. Okay, so guys, let's recap real quick. Law of sines is going to be this formula up here. You're saying side A over sine of angle A equals B over sine over the sine of angle B equals side C over the sine of angle C. So if we have this example right here, so what we're given here is that we had 40 degrees, we had 25 degrees, 40 degrees for A, 25 degrees for angle B, and we're given side little c up here. And we're going to end up solving for the other information here. So from this, how do we do that? Remember, your three angles add up to 180. That's how we got that angle C is 115 degrees. And if you're looking for, let's say, side A, how do we do that? Remember from this over here, from your law of sines. Remember, in order to do this, you have to have both of something to be able to solve. Okay, and here what we were given is we're given both the C's. We're given side C and we're given angle C, or we solve for angle C. So once we got that, we could solve. So if we're looking for little a, just to recap, I didn't know what little a was. I didn't know that angle A was 40 degrees. And I had both the C's, of course. I had little c is 20 and big C is 115 degrees. So you put that in here. That means you're saying A over sine 40 equals 20 over sine 115 degrees, cross multiply. So A sine 115 equals 20 over 20, actually equals 20 sine 40, and then we don't want the sine 15, so divide both sides by sine 115. This gets us down to A equals 14 point blah 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 blah, and so that's just going to be A equals 14.2. And we can do the same thing for B. Plug in information. You didn't have little b. You had big B is 25, and then of course you had both the C's, cross multiply, get it down to B is going to be 9.3, and that is how we find all our information using law of sines. Alrighty.